Hello all, this is Vani from R.M.K College of Engineering and Technology. In this video, we are going to discuss about source coding technique in information theory. So what are source coding techniques? And one of the source coding technique, Huffman code, will be discussed in this video. So the symbols generated by sources are to be coded by source coder in order to remove redundancy. The main objective of source coder is to efficiently code the symbols in order to save power and bandwidth. So the main objective is to represent information as accurately as possible using very less number of bits as possible. Hence, the redundancy from the source needs to be removed in order to code the symbols efficiently. So the source coding techniques, which are also called as source compression coding, are variable in length. So the classification of source coding technique includes two categories of coding technique: Shannon Fano coding and Huffman coding. So in the previous videos, we have discussed about Shannon Fano coding. And the main drawback of Shannon Fano code is there may be two different codes for the same symbol depending upon the way we build our tree. Also, we have no unique code. That is, a code might be a prefix for another code. Hence, it is not obeying the uniquely decodable property. Hence, Shannon-Fano coding does not guarantee optimal codes. So, in order to overcome these drawbacks, we are going to learn about Huffman coding technique. So the Huffman coding is a lossless compression of data, and it uses variable length encoding technique. The character which occurs most frequently gets the smallest code, and the character which occurs least frequently gets the largest code. The procedure for building Huffman coding is all the given source symbols are listed in the order of decreasing probability. The last two source symbols are then combined in order to have a probability which is equal to sum of the two original probabilities. The procedure is repeated until we are left with final list of source statistics with just two symbols. The code for each source is found by working backward and tracing the sequence of zeros and ones assigned to that symbol as well as its successors. So let us understand this procedure with an example. So let us find the entropy and efficiency of the following symbols using Huffman coding, where the probabilities of symbols x1, x2, x3, x4, x5 are given as 0.3, 0.15, 0.25, 0.05 and 0.25. So as told in the procedure, first we have to arrange all the probabilities in decreasing order. If we see here, the decreasing orders are x1, x3, x5, x2 and x4. That is, the corresponding probabilities 0.3, 0.25, 0.25, 0.15 and 0.05. So what we are going to do further is we will be adding the last two probabilities and then we will be combining in order to find out the code for each symbol. So as a step 1, we are going to add the last two probabilities 0.15 and 0.05, and they will be assigned with the codes of 0 and 1 respectively. These contribute to 0.2, and as it is the least probability, it is kept in this order. So this shows the first reduction. For second reduction, again we are adding the last two probabilities 0.25 and 0.2. Now the total comes to be 0.45. As per the procedure, it has to be kept in the top as it is having more probability compared to 0.3 and 0.25. Now again We are going to combine the last two probabilities 0.3 and 0.25, which are assigned with the codes of 0 and 1 respectively. Now when we add 0.3 and 0.25, the resultant probability is 0.55, which has to be kept at the top compared to 0.45. So again 0.55 is assigned with the code of 0 and 0.45 is assigned with the code of 1. Now let us find out the code for symbols x1 to x5 respectively. So the first code is given by, you see the trace of the code, the first code word for x1 is given by 00. Similarly, we can find out the code for x3. If you see the trace, the code word for x3 is 10. The code word for x5 is 01. The code word for x2 is 011. And finally, the code word for x4 is 111. In order to calculate the parameters entropy, average code word length, efficiency, and redundancy, we can substitute all the values in the given formula. And after substituting, the entropy is calculated as 2.1465, average code word length is 2.2, and efficiency is h of s by L bar, which is equal to 97.7%. This shows the efficiency of Huffman code for the given problem. Thank you.